A 15 kilowatt-hour peak solar system that provides energy to an entire house during the sunny season generates a fraction of that amount of energy during the winter. This is precisely where small wind turbines can be utilized, as the wind turbine season is asynchronous to photovoltaic (PV) systems, during which the sun is statistically weaker in Europe and winds are heavier, which impacts off-grid living. Numerous corporations have already acknowledged this potential for off-grid users and have abandoned residential small wind generators, despite the fact that they may serve as a substitute for solar panels or as a supplement to them entirely. Skywind has developed a compact wind turbine manufactured in Germany that generates electricity at a peak output of 1,000 watts and commences operation at a wind speed of 4 meters per second. Notably, a single turbine operates at an average wind speed of 6 meters per second, yet it silently generates more than 1,000 kilowatt-hours of electricity annually. Power Collective and Flower Turbines, on the other hand, have developed similarly intriguing ridge blade rooftop turbines. Is the wind speed sufficient in your wind conditions region to support a rooftop wind turbine? This is the most crucial inquiry. If you are considering the installation of an off-grid wind turbine in your region, it is worth noting that the wind map published by the National Renewable Energy Laboratory indicates that the central part of the United States has the greatest average wind speeds, making it the most favorable area for wind energy. Fortunately, in this age of the internet, it is possible to monitor real-time wind speeds worldwide at windy.com. Detailed real-time measurements reveal that the current wind speed in many regions spanning from the Midwest to Texas is between 8 and 17 knots, or 9 to 20 miles per hour. In some areas, 30 knots have been recorded. Given these conditions, wind turbines would make perfect sense. However, if that were so straightforward, why aren't wind turbines more prevalent? Skywind, the company, has unveiled a 20-kilogram device that is practically capable of being deployed on any rooftop. The rotors are constructed from aviation aluminum, which renders them notably lightweight yet durable. Conventional rotors are unnecessarily intricate in nature, which complicates the manufacturing process. However, residential wind turbines must be as inexpensive as possible to remain competitive. To achieve this, the rotors are precisely bent at the ideal angle and location to generate an aerodynamic profile. Furthermore, they possess a unique characteristic. As seen on aeroplanes, it is composed of merely 2 rotor blades with wingtips attached. These blades increase efficiency and decrease pollution. Small turbines function similarly to industrial turbines. When the wind blows, kinetic wind energy is converted to mechanical energy and then to electricity using an integrated generator. An automatic shutoff system is also incorporated to safeguard the turbines against overloading and destruction during storms. This particular design, known as Skywind, has been granted a patent, making it the only micro wind power system globally to offer a guaranteed performance curve with a WEI. An average American household uses 10,000 kilowatt-hours of electricity annually. Therefore, to meet this demand, 10 of these 1 kilowatt-hour turbines are required, which is a $30,000 investment. However, these systems should be used in conjunction with solar panels to generate electricity, even during inclement weather. Therefore, is this mini wind turbine the most effective way to generate wind energy at home? Concerning perpendicular wind turbines, Flower Turbine. Flower Turbines has introduced a highly promising vertical wind turbine project with 3 different sizes. At a wind speed of 1.5 miles per hour or 0.7 meters per second, the windflower begins to generate electricity. This is a truly aesthetically pleasing solution, and the smallest model weighs only 18 kilograms, making it ideal for residential use. Additionally, the manufacturer disclosed that flower turbines are not operated in isolation. Each turbine becomes 20% more efficient with the placement of at least 3 turbines, and each becomes an additional 50% more efficient with the placement of 5 or more turbines. This is due to the air turbulence and suction generated by the flower turbines. Despite generating 1,300 kilowatt-hours of electricity annually and operating at an average wind speed of 5 meters, each of the 5 small turbines costs €3,000 to acquire. The cost of 5 turbines would amount to approximately $15,000, generating 1,300 kilowatt-hours of electricity annually. In contrast, the flower turbine would be considered rudimentary after 30 years and that is merely an approximation. An additional 1 to 2% annual maintenance cost must be accounted for. However, the most intriguing wind turbine for residential use is the Ridgeblade Power Collective's turbocharged wind turbine, which bears the name Ridgeblade and is mandatory. One notable characteristic of this structure is its effective utilization of a conventional pitched roof configuration. Utilizing the benefits of so-called aeolian wind, a Ridgeblade harnesses the force of the wind by utilizing the available area of a pitched roof. The focus effect significantly increases the electricity yield. By employing a 45 roof pitch, this wind turbine is capable of generating 220% more electricity at equivalent wind velocities. The Ridgeblade remains operational during storms due to the self-regulating nature of the rotor blades, which results in flow separation and torque loss at high wind velocities due to the distance between them. This is how the Ridgeblade manages to generate power during storms and withstand speeds exceeding 100 miles per hour, whereas other wind turbines fail and must be halted. Furthermore, its design complements the house's aesthetic and has the least noticeable impact. The unobstructed roof surface may also be utilized for solar panels, rendering it an ideal amalgamation for an autonomous off-grid dwelling. To illustrate, this particular roof comprises 7 RB1 turbines and generates 5,000 kilowatt-hours annually at a wind velocity of 5 meters per second. Within Europe, 2 architecture firms, one in Italy and the other in France, are presently devising internal projects involving these RB1 turbines. Unfortunately, we were unable to locate a price for the RB1, a smaller residential wind turbine. However, as the product approaches mass adoption, more information will undoubtedly become available. If you are interested in updates regarding the Ridgeblade or other residential wind turbines, please subscribe to my channel and click the bell icon to be notified of any new videos. Until then, you can observe how electricity can be generated at a reasonable cost.